Welcome viewers. I am Amit Sohel from Swami Vivekananda Institute of Science and Technology, Department of Civil Engineering. Now, today's our discussion matter is a vital chapter from solid mechanics, that is torsion. So let us begin. First of all, what is torsion? We have to know that what does it mean. So it's actually in industry level. Uh, Actually, it's the working principle behind the circular shaft. And the cause of torsion, you can say in other words, torque is the cause and torsion is the effect of the torque. So torque or turning moment or twisting moment, whatever you say, that implies the torsion. In factories and workshops, shafts is used to transmit energy from one end to other. To transmit the energy, a turning force is applied either to the ring of a pulley feed to shafts or to any other suitable point at some distance from the axis of shaft. The moment of couple acting on the shaft is called torque or turning moment or twisting moment. Okay, next. Here is the schematic diagram where you can actually visualize the torque, how it is applied actually. There is a mistake uh, of in this equation. I will elaborate it. Just understand the torque. If it is a cross section of a shaft, basically you can compare torsion, the phenomenon of when you wash your cloth, you actually use torsion as a tool to extract the additional water present in the cloth. Afterward, the washing. So it is a phenomenon which will decide later what. So if we elaborate, torque, torque is the product of force and diameter of that section where it is applied. So that's mean torque is the turning force into diameter of the shaft. So basically T is equal to F into R, not 2R. This is actually mistakenly written. It will actually T is equal to F into R. Okay, and the significance of this abbreviation, which is letter T, F and R respectively are, here T is representing the torque, F is the turning force, and R, there is also a mistake, that is R, radius of the shaft. So what is the unit of the torque? It is very simple, Newton mm or kilometer mm. If the diameter of the shaft, if it is in millimeter, say, then force into this distance will represent the torque. Okay, if it is in meter, then basically kilometer meter will be the unit of the torque. Next, here is the basic parameters we are establishing. Now, what is it? First point and the most foremost point is the angle of twist. Angle of twist is the main parameters where the torque applied, means the effect of the torque, which is actually torsion. The torsion begins from here. So what is angle of twist? When the shaft is subjected to torque T, point A on the surface of the shaft come to A dash position, the angle AO dash at the center of the shaft, the angle AO and A dash at the center is the angle of twist. Okay. So angle AO A dash is the angle of twist. Angle of twist is measured in radian. Mind it, why it is measured in radian? Because you are measuring it as the rotational displacement actually. And we already know that 1 radian is equal to 360 degree divided by 2 pi degree. So you have conversion factor here, that is 1 radian to degree. The conversion factor will be 180 divided by pi. Okay, in order to find out the angle of twist in degree, you have to multiply radian into 180 divided by pi. Next, shear stress. It is also an important factor. You have to find out the shear stress, where the shear stress is coming from, where shear stress is coming. Shears, if the shear stress is not present in the system, then there will be no torque, then there will be no torsion. If there is there is certain amount of shear stress in this material, which is called sap, or any material where you are applying torque or torsion, there have to certain amount of shear stress, otherwise torque or torsion will not be applied. Okay, so when a shaft is subjected to equal and opposite end couples whose axes coincide with the axis of the shaft is said to be in pure torsion. Okay, and at any point in the section of the shaft, stress will be induced. The stress is called, this stress is called shear stress in the shaft. Next, so what is the strength of the shaft in terms of shear stress or angle of twist, whatever it is? So maximum torque or power the shaft can transmit from one pulley to another is called strength of shaft. For solid circular shaft, this is two types. One is solid, and second one is hollow. That means solid circular section will have uniform cross section, and hollow circular shaft will be like this. From the center there will be two diameters. There will be two different diameters. That is outer diameters. It is commonly defined by capital D terms, and second one is inner diameters. It is defined by letter D. Okay, so we have to deal with that. So for solid circular shaft, maximum torque is T is equal to pi divided by 16 into tau into 10 to the power 3, where D is the diameter of shaft and tau is the shear stress of the shaft. Okay, we have to remember this formula in order to find out the maximum torque. Next, for hollow circular shaft, what was I telling? There are two diameters. One is outer and second one is inner. Okay, so pi divided by 16, same formula, same multiplication factor into tau, d to the power 4 minus later d to the power 4 divided by outer diameter, where capital D, actually it is capital D is equal to outer diameter of the shaft and later D is the inner diameter of shaft. What are the assumptions? When it comes to as a theory question, there may be asked, what are the assumptions behind theory of torsion? So following assumptions are as follows. The following assumptions are made while finding out the shear stress in the circular shaft subjected to torsion. The material of the shaft is uniform throughout the length. Okay. First assumption, the twist along the shaft is uniform. Your twist should have to follow the uniformity. The shaft is of uniform circular section throughout the length. Cross section of the shaft which are plane before twist which are plane before twist remain plane after twist. Already which are straight before twist remain straight after twist. So basically condition will be uniform, then this torsional formula will be valid. Okay. Now on another terminology which is important in terms of torsion, that is polar moment of inertia. You don't know about moment of inertia, what is it actually? So polar moment of inertia is defined by capital J alphabet. The moment of inertia, it is actually a resistance force of a plane area with respect to an axis perpendicular to the plane of the figure is called polar moment of inertia. As per perpendicular axis theorem, you have to remember just this. Polar moment of inertia for a circular shaft is equal to pi by 32 into d to the power 4. If the hollow sections comes into the account, then this diameter will be different. Okay. Now let us understand the written content through the picture, so it will be more convenient to you. Here is the picture. It is a circular shaft which is cut into a sample, a piece where you can uh, visualize the torque and the after effect of the torque. So basically, it is the external torque, okay, and internal torque is acting as a couple, and the shear stress is present in this system. So there will be a torsion. There will be a torsion, and what is the main point here? There it is, angle of twist. There it is, angle of twist, and the angle from the one end, uh, another end or one end, whatever you say, it is the angle of shear. It is the angle of shear. Because of shear force, it offers these angles. Okay, and if we see second picture, there are abbreviation indicating the initial position and the after position and the after effect position, that is OB and OB dash. The angle of shear is defined by phi and angle of twist is defined by theta. Okay, next. The key point, what should we remember? That is the most important. You will find this equation searching torsion from any search engine. You will find this equation, that is T divided by J is equal to G theta by L is equal to tau divided by R. And what are the importance here? I will discuss it later. Let us see the importance of these alphabetic terms. So first, T is the torque or twisting moment, D is the diameter of the shaft, J is the polar moment of inertia, tau is the shear stress, G is the modulus of rigidity, theta is the angle of twist, L is the length of shaft, R is the radius of shaft, and so on. So if we rearrange the equation, we can have these terms. T is equal to, if we rearrange these two terms, actually T by J is equal to tau divided by R, then we have these terms. So T divided by J is equal to tau divided by R. From this equation we can evaluate this equation. T is equal to tau divided by JR, where now we can simplify more by considering J divided by R as Z subscript P. What is it? It is actually considered as polar modulus. So Zp is equal to J divided by R. So Zp is equal to J divided by R. Okay. Next. So there are some conditions from the previous equation. If shear stress Now, a given condition, shear stress is constant. If we consider the shear stress is constant of a solid circular shaft, then torsional resistance of the shaft is proportional to the polar modulus. Okay? The polar modulus of the section is measure of strength of the shaft in torsion. Polar moment of inertia for solid circular shaft J is equal to pi d to the power 4 is divided by 32, and polar moment of inertia for hollow circular section, that is J is equal to pi into d to the power 4 minus later d to the power 4 divided by 32. Next, torsional equation, let us see again the equation. So T divided by J is equal to d theta by L is equal to tau divided by R, where if we consider only these two terms, if we consider only these two terms, T divided by J is equal to d theta by L, we can rearrange the equation like this for twisting angle of twist. So theta is equal to TL divided by Gj. So theta is equal to TL divided by Gj. For a given set, if G, G, L and J are constant, then angle of twist is directly proportional to the twisting moment or torsion. And Gj here is represented, Gj representing the torsional rigidity. Now, let us simplify. It is also an important term. Why we are simplifying these terms various form? Actually, it is helpful when uh, you attending a numerical question. Then you don't have to rearrange the main equation. So keeping in mind all necessary possibilities actually. So Gj divided by L is equal to T divided by theta, where L and theta, if L and theta is 1, if L and theta is 1, if L and theta is 1, then torsional rigidity is directly proportional to the torsion or torque that produces a twist of 1 radian in a shaft of unit length. Okay, next. The last point in the torsional question which may ask in your semester examination or in your competitive type examination, that is what is the power, because if we remember the first slide, there was a term that the tap is using to transmit power from one end to other end, from one pulley to other pulley. So we have to consider how much power is transmitting to the shaft. So in order to finding the power transmitted to the shaft, you have to know the work done by the torque. The work done by the torque is T into 2 pi n Newton meter per minute. Power transmitted by shaft is P kilowatt. Now, if we convert in watt, which is equal to joule per second, which is equivalent to Newton meter per second, then P into 10 to the power 3 Newton meter per second. If we convert second into minute, then we will have the power transmitted by the shaft is equal to 60 P into 10 to the power 3 Newton meter per minute. Okay. Now equating work done to the torque to the power transmitted by the shaft, then what will you have? That is P is equal to 2 pi N T divided by 60,000 kilowatt. If we convert it in horsepower, what we will have? That is P is equal to 2 pi N T divided by 45,000 horsepower. Now, what are the importance? E, that is denoting power transmitted by the shaft. N, rotational speed of the shaft in RPM. T, average or mean torque in Newton meter. Okay. Now there are some special condition. If I dictate it like this, it will be like this. Average or mean torque is considered for computing the power. For determining the diameter of the shaft, the maximum torque is taken into account because the maximum shear stress developed is ensured to be within safe limits. Alright, then let's take an example to evaluate the parameters. So what is asking by this example? Let us see. Calculate diameter of shaft. So we have to calculate the diameter of the shaft. This go through the next line. Calculate the diameter of the shaft to transmit at a speed of 15 Hz. The maximum shear stress should not exceed 60 megapascal. So here P is given by 10 kilowatt, N is 15 Hz. So in her, if we convert in cycle per second, then Hertz equivalent to cycle per second. So 15 Hertz is equal to 15 cycle per second. If it is converted in rotation per minute, that is called RPM, then 15 into 60 RPM, that is 900 RPM. So unit is set to be used, and shear stress is bounded 16 megapascal. Now, if we remember the power formula, then P is equal to 2 pi NT divided by 60. Here P is 10 kilowatt, but we are dealing with Newton per. Here we are dealing with Newton per meter or millimeter. Let us see Newton per meter, I think. So 10 into 10 to the power 3, 2 pi n. N is 900 into T divided by 60. From here, so you are dealing with Newton per meter. That's why we are multiplying 10 to the power 3. If we are dealing with Newton per millimeter, then we have to multiply 10 to the power 6. From this equation, we can have T is equal to 106.10 Newton per meter. So, if we recall the equation for torsion, then we will have a solid circular shaft T is equal to pi by 16 into tau into the power 3. From here, if we equating, now equating 106.10 or 10 into 10 to the power 3. Now why we multiplying 10 to the power 3? Now we are dealing with Newton millimeter divided by is equal to pi by 16 into 660 into 10 to the power 3, and our main objective is to find out the diameter. From here 10 to the power 3 equal to 9006.0. From here we can have the diameter of the first circular shaft is 20.80 millimeter. So this is the end of the session of torsion. We will discuss some more important example if necessary. Otherwise, we'll see you uh, in next session with more important topics as like today. Thank you.